Okay, so today we're going to talk about, we're just going to review some of these basic phylogenetic concepts that we went over in the beginning, but I think maybe we went over a little too quickly, and I'd just like to review these concepts. I think they'll make everything a little clearer as we go through the rest of the semester. And so does anyone know who or what this image is here on the screen?
Is it Linnaeus's?
Close. It's Charles Darwin's initial sketch of what he thought evolution might look like, which is kind of amazing that he just came up with this in the 1800s, like on his own, which is pretty amazing. And then this quote is actually, I think this is a great quote. Does anyone know who said this quote?
No.
So this is also Charles Darwin. So I think it's a really cool quote because it shows that even people who are absolute geniuses who will revolutionize the world have days where they feel off. And I think that's important for people to always keep in mind. So we're just going to start with this little exercise. So the phylogeny below shows two different hypotheses regarding the relationships among vertebrates. The phylogeny on the right groups sharks and ray-finned or actinopterygii together as a clade, and the phylogeny on the left does not. Which hypothesis do you think is more likely to be accurate and why? So think about this for a minute or two, jot down some answers, and then I'm going to put you in breakout rooms to discuss, and then we'll come back together. Okay, maybe next time we'll do 3 minutes. I don't know, 2 minutes seems pretty quick. So let's have one person from each group just briefly share what they thought. I don't remember which groups you were in.
I'll go. So me and Michael were in a group together, and him and I decided on hypothesis 1 because we remembered from when we talked about the parsimonious, which is the least number of changes in order to get to that evolution. So when we looked at both of the phylogenetic trees, we saw that hypothesis 2 had bony skeleton breaking off twice. So you had more changes in that one. So we decided that hypothesis 1 would probably be the more likely phylogenetic tree.
Yeah, and does anyone from the other group want to add anything? Okay, so we're just going to go through some of these basic concepts, and then what I forgot to mention during housekeeping is at the end, I'm just going to give you a brief overview of how to use Google Scholar so you can effectively find your sources for your annotated bibliography. Okay, so understanding phylogeny is a lot like reading a family tree, and the root of the tree represents the ancestral lineage, and the tips of the branches represent the descendants of that ancestor. And so as you move from the root to the tips, you are moving forward in time. All right, so pretty basic. Here's the root, and these are the tips. And instead of 1, 2, or 3, you could name those ABC, you could name those fish, sharks, whatever, or individual species. And so when a lineage splits, which is usually known as a speciation, it is represented by branching on a phylogeny. So when a speciation event occurs, a single ancestral lineage gives rise to 2 or more daughter lineages. So this root, the ancestral lineage, splits, and then there are 2 descendant lineages. And then, so phylogenies trace patterns of shared ancestry between lineages, and each lineage has a part of its history that is unique to it alone, and parts that are shared with other lineages. So if we look at this image here, we have 3 different lineages, right? Lineage A, lineage B, lineage C. And so if we go through this graph, we see that starting from the ancestral stock, there's a shared history among B and C. There was a speciation event that broke off A, and then the ancestor of B and C. And so B has its own unique lineage, C or history. C has its own unique history, but then B and C share a history separate from A. But when you look prior to when A and BC split off, that's where they share a lineage. And similarly, each lineage has ancestors that are unique to that lineage and ancestors that are shared with other lineages, and that's what we refer to as common ancestors. So if we're looking at the graph, we see that where this speciation event, where this split is, that represents the common ancestor of A, B, and C. And then if we follow the tree up to where this green square is, that's the common ancestor of B and C. And then C, or the branch represents the unique ancestor of C. So you could also put one of these here for B and here for A. Does that make sense? We're just going pretty logically from the root up to the tips. Okay, so we're not going to do a breakout group for this one, but let's just stop and think on our own. So which taxon on the so the taxon are these letters, right? These tips. Which taxon on the tree below is most closely related to D, which is this one? Is it A, B, C, or all of the above are equally closely related to D? So just think for yourself for a couple seconds, and then maybe I'll call on one of you randomly. And this is just something we're gonna work through. So if you get the answer wrong, that's perfectly fine, but we'll work through it together. So let's say, who wants to do it? Oh man, I don't like cold calling on people. Let's have someone who hasn't spoken today volunteer to give an answer.
I think it's C.
So which taxon is most closely related to D? C? Yeah, definitely that's what I would agree with, right? So they share a recent common ancestor. And so while while A and B and C all certainly share a common ancestor at some point with D, C has the most recent common ancestor, right? Does anyone have any questions about that one? Okay, good job. And so we often talk about clades. And so a clade is a grouping that includes a common ancestor and all of the descendants, living and extinct, of that ancestor. Using a phylogeny, it's easy to tell if a group of lineages forms a clade. You could imagine clipping a single branch off the phylogeny, and all of the organisms on that prune branch make up a clade. So this is really one of the strengths of phylogenies, is that you're getting your ideas down on paper in an easily digestible format. And so if we look at this figure, we can see that this green, like if you were to cut right, oh, I can draw on this, can't I? Let's see. You see that? Oh, cool. So if you were to cut this tree right here, everything after that cut is a clade in this green group. If we were to make a cut right here, we just have this single branch. That still represents a clade. A clade can be a single branch or a single line, right? It doesn't have to be expansive. Alternatively, you could make a cut here, right? And then all of this is a clade. Or so I guess you don't even have to make a cut, right? Just all of that is a clade. Alternatively, if we were to draw this red circle or red square here, right? That is not a clade. Why is that not a clade?
Because it doesn't include the other descendant over here or any of these, so it's not complete with the common ancestor.
Exactly, right? So you would, in order to get this box, if you were to using the cutting analogy, you'd have to make 2 cuts, right? And if you have to make 2 cuts, then it's no longer a clade. And what is the term we would use to refer to an example like this?
Isn't it paraphyletic?
Yes, paraphyletic. Whereas clades are monophyletic. So you can remember that mono means one and para means many or multiple. And then this orange box is another example. It's not necessarily a matter of just making 2 cuts to not make a clade. If you exclude a group, then you're also making a paraphyletic grouping. So I guess you'd have to cut here, right, and then here. So I guess that is 2 cuts.
So I have a question.
Basically,
Oh, go ahead.
Oh, sorry.
No, go ahead, Katie, you're good.
So basically, as long as it's 1 cut, it can be a clade.
Yes.
Okay.
Yep. So you could cut here and be a clade. You could cut here and be a clade, because then that would be this, and that would be this.
So I have a question.
Yep.
I don't know if anyone can see if I try to draw on here, but would this
So
be a clade?
I don't think I can see.
You can't see it?
Oh,
Okay.
it just showed up. It's in the blue.
Over
Oh,
here.
really?
You
Oh,
don't see it?
oh, I did. Oh, cool. It showed up on my other monitor.
Oh. So would that be a clade or would that not be considered a clade?
That would not be considered a clade.
Okay.
But that's because you're including this. So instead, if you cut here, is it showing up? No, it's not. Why is it not working? There we go. That would be a clade.
Okay.
But in order to make that a group, you'd have to make this second cut to exclude that tip.
Oh, I see. Okay. Got it.
Yep. So just it's based on just including whether or not you included this recent common ancestor or not.
Mm-hmm.
Good questions. Okay, and so clades can be nested and often are nested within one another. And the word you'd use to describe it is it's a nested hierarchy. And so a clade can include thousands of species or just a few. And so if we look, we could have this yellow box, that's a clade, right? Because we made this cut here. But we could also make the cut here and have this blue clade. So the yellow clade is nested within this blue clade. And similarly, we could then the yellow one is nested in the blue one, which is also nested in the red one. So the difference from what we were looking at before and what we're looking at now with nested clades is that these squares are encompassing the other ones. They're not excluding it, right? So these are, if you're encompassing it, then you're just creating nested clades. Whereas if you're excluding them, then you're creating paraphyly, which is generally something we try to avoid. Does that make sense?
I'm kind of confused. Like,
Sure.
compared to the blue and the red, would the red be more accurate than the blue because there's more nesting included?
Oh, so that's a great discussion point. So when we're talking about nested phylogenies, we're not talking about accuracy. So this is more of just a broader concept. So this is kind of like thinking that hypothetically we could call these. Let's see. Can I have text? No. Okay, so let's just call these, let's say these are, oh my gosh, typing with a mouse. let's say yellow was mammals. Mammals are nested within, or sorry, let's not say mammals. Let's say these are rodents. Oh my God, that's terrible. Rodents are nested within mammals, and mammals are nested within vertebrates.
Okay.
So you still have rodents that are nested within mammals, which are nested
Within vertebrates. Okay.
vertebrates.
That makes sense.
Okay, good question.
Yeah. Thank you.
And so there's a lot of information that's kind of hidden in a phylogeny if you know where to look. So often we're not going to have these kind of color-coded boxes or labels, but once you kind of have this understanding, then you can really pull a lot of information out of them. So how do you tell which organisms on a tree are most closely related to another? It's tempting to read these right to left, but that's not how you read a tree, right? You read it from bottom to top, or from the root, the ancestor, to the most recent. So the order is not meaningful. Instead, we're looking at the branching pattern. And so we're looking for those common ancestors, these nodes, right? So not every tree draws a node, but you could always draw a little node where the branching happens if that helps you. And so common ancestry refers to the fact that distinct descendant lineages have the same ancestral lineage in common with one another. So this is kind of just a more advanced way of saying what we were talking about before. And so if we look at this graph, this orange set of lines represents the shared ancestral lineage that leads to the blue lineage and the pink lineage. And where the branching happens is where that recent common ancestor is represented, and that's the node, right? So feel free to mentally or physically draw nodes on your graphs if it helps you remember that those are where common ancestors are represented. And so we could flip this around, right? So you just look for the root, and that's where the oldest part of the tree is. And so if the root is on the bottom and it's moving up, then old is on the bottom and newer is on the top. But if we were to rotate this and the root was over here, then it would go that way. Does that make sense? So these are, we're going to go over just a couple misconceptions. This is kind of like in the tree thinking chapter we read. They're trees, not ladders, right? And so evolution produces a pattern of relationships among lineages that is tree-like and not ladder-like. And so this is what we've been talking about. Do you know what this symbol means?
Not equal to.
Yeah, not equal to. Another way that some people write this is an exclamation point in front of an equal sign. So like if I'm doing programming, computer programming, that's how I type that into the computer. So you might see that elsewhere. And so, right, we're thinking about trees, which we've been talking about now for a couple weeks, not a ladder, right? So the way to read this is not that A evolved into B and then B evolved into C and then C evolved into D, right? That's how people used to think, but we understand that evolution doesn't happen like that. So let's do just another stop and think. Which taxon in the tree below is most closely related to A this time? Is it B, C, or all of the above are equally closely related to A? Let's give you a couple more seconds to mull it over. This one's a little trickier than the previous one. All right. Let's. I'll ask someone that hasn't responded yet today to volunteer their answer.
Would it be all of the above because of that one single common ancestor node that kind of leads to all of them?
What does everyone else think? Or what other?
I think it's B because although they're not sister groups, you only have 2 different common ancestors, whereas like in C and D, you have like an extra trait evolving.
Any other answers?
I agree with Zach.
I would say I was also thinking B.
Okay, so actually the first answer, Katie's answer, was correct, and so that's why this is kind of a tricky one, right? So it's tricky because B is closest to A, right? So that's our intuition, is that these are more closely related. But remember that we can swivel these, right? So we could redraw this and have it. So all of these are more closely related to A because B, C, and D all kind of have this, their common ancestor, or well, I guess here. So this is a lineage, and this is a separate lineage, and their most recent common ancestor was right here in this node.
So are you kind of saying that like that's B, C, and D are like genetically like equally related to A, but C and D may be looking slightly different?
Well, yeah. So that's a great point. So this clade that represents B, C, and D is, so we're basically looking at this clade and this clade. So everything that comes after, they share this common ancestor with A, and so C and D are more closely related together than they are to anything else, and C and D are more closely related to B than they are to anything else. But B is not necessarily more closely related to A. So B is more closely related to C and D, but they're all equally closely related to A. So it's kind of confusing, but is that starting to make a little bit of sense?
Oh, I see. Yeah, I'm seeing that now.
This is definitely something that's a little confusing. So I'm going to make a note of this, and I'm going to try to find some more tangible examples of this, and we'll come back to this, and we'll talk about this on Monday to just make sure we drill this point home, because it is unintuitive.
So I have a quick question.
Yeah.
So before, when you were saying that like you can like flip it, so you're saying like you could flip this whole thing, and like so D would be here, and then C and B. So like they're technically all still close.
Yes. Yeah. Exactly. Okay. Yep.
Got it.
Okay, and so this is a similar way of looking at what we previously talked about. So because we tend to read them from left to right, but there isn't necessarily a correlation of advancement. So this is another way of saying they're trees and not ladders. And then for any speciation event on a phylogeny, the choice of which lineage goes right and left is arbitrary. The above phylogenies. Oh, okay. So this shows how you can flip these trees. I forgot that I had a slide about this. All right, so we can easily you can rotate wherever you make a cut, and you can easily switch these two around. Or if you were to cut here, then this entire thing could be switched, and that could go over here. All right, so let's just do one more of these. Which is most closely related to C? Is it A, B, or B and D are equally closely related to C, or all of them are equally closely related to C? This is tricky. Well, I'll say it's tricky in the way that multiple choices are tricky. I would say actually this is not that tricky of a question, but the way the multiple choice answers make you think it might be tricky makes it tricky. Does anyone want to volunteer an answer?
Would it be C? I mean, sorry, D. Would it be D is closely related to C?
Yes, yeah, absolutely. Because they share this recent common ancestor, right? Relative to the other ones. And so the reason I said it can be kind of tricky is because multiple choice, like when someone throws in these like A but not B or B but not D multiple choice, you start thinking that, well, those weren't in the previous multiple choice questions, so why did they add those potential answers? Is that one of them? And so that's kind of that can trick you up when you're thinking about multiple choice questions, but so keep that in mind. Right, the multiple choice, sometimes the questions, you try to come up with the answer before looking at the multiple choice answers.
So is that like a more clever way of slide 9 of trying to trick us?
Yes, yeah, yep.
Cool.
Could it also be B, C, and D? Because they all branch, I don't know if I can draw, but like that one common ancestor that like leads off to B? Or would it just be C and D because they have that separate common ancestor?
It would, in this case, it would, if you were to say of these, which is most close related to C, then it's just going to be D. And so it would just be D. But B is then more closely related to C and D than A is, because B shares a recent common ancestor with C and D here, and A doesn't share a recent common ancestor with C until right here.
Okay.
So always, if something is asking you to look or it is asking you what is the most closely related taxon, or what is it most closely related to, look at where those common ancestors are and how many different steps you would have to take to get there.
Okay.
It's a great question. And this is just kind of an example to kind of ground things. So humans did not evolve from chimpanzees, which is a common misconception about human evolution, right? Humans and chimpanzees are related, and we share a recent common ancestor that was not necessarily a chimpanzee or a human, right? It might have been chimpanzee-like or human-like, but it was not a modern chimpanzee, right? So this represents the most recent common ancestor between humans and chimpanzees. And in fact, the most recent common ancestor, or the most closely related thing that exists today to a chimpanzee is a bonobo. Have you guys heard of bonobos before? So their other name is the pygmy chimpanzee, and it's basically just another species in the chimpanzee genus. They're smaller, they have a darker face, and are you guys familiar with the idea that chimpanzees are like hyper violent? Have you guys come across that idea? And they like will hunt other monkeys and they'll kill each other and they go to war with each other. And that's all true. But the opposite is true of bonobos, which you could call the pygmy chimpanzee versus the common chimpanzee. But bonobos are actually super peaceful, and they actually, this is kind of weird, they trade sex instead of using violence to get what they want. It's like really, really weird. Go watch a YouTube video about it. Super weird, really, really cool. And as humans, we are more closely related to chimpanzees than we are to gorillas, which is pretty amazing.
Why is it chimpanzees and not gorillas?
So humans and chimps, we share this recent common ancestor here, but we'd have to go down a step for us to share a common ancestor with gorillas. So we are super closely related to gorillas, but we are more closely related to chimpanzees because we share a more recent common ancestor than we do with gorillas.
Gotcha. Okay.
We'll finish these on Monday. before we go over fish. We'll just go through them quickly. But right now, I just want to show you quickly how to use Google Scholar